Ruska's TEM was taking off, a German physicist named Otto Scherzer published a paper claiming that the microscope was about to hit a brick wall. There was a flaw in the electromagnetic lens, he wrote, that was completely unavoidable. For an electron to make it to the focus of the lens, it needs to be deflected by a specific amount. If you simplify its trajectory, you can define that ideal deflection with this angle theta. This angle depends on the horizontal distance of the electron from the optical axis, and how far down the axis the focus is, also known as the focal length. The shorter the focal length, the stronger the magnification. If you graph this angle as a function of distance to the optical axis, you'll see that it can be approximated as linear. The problem is that the magnetic field doesn't scale linearly. It's much stronger near the edges of the magnet. So if you plot the curve for the actual deflection of the electrons, you'll see that the magnetic field over-deflects the electrons further out. Their angles are bigger than they should be, so they end up focusing before the rays in the middle. And as a result, the focus is spread across the optical axis instead of being contained in a single point. The blur starts out around the edges of the image, but it gets worse the higher the magnification. This is called spherical aberration, and it distorts every radially symmetric magnetic lens.